Hey everyone, it's Mr. Canfield. We're doing 4.8 Builders for Hire today. So I'm going to give you the activity that we're going to do in class. I'm going to explain it to you and then give you a chance to actually go do it. So in this one, we must have side AB is 7, side BC is 9, and side AC is 12. So we'll use inches. In project number 2, side DE is 8 inches, side EF is 10 inches, and the measure of angle E is 100 degrees. And then for building project 3, we've got side GH is 12 inches, side HI is 8 inches, and the measure of angle G is 30 degrees. So what's going to happen is in the class, we're going to build these, or we're going to draw them, and then we're going to look around the room and see how they relate to one another and see what we notice. So go ahead and go off and do that if you want. Spoilers are coming in 3, 2, 1. Okay, so what we're going to see is students that build this triangle, 7, 9, and 12, what they're going to find, these are 3 sides. And we're going to find there's only a single triangle in the whole class, and it's this, over and over and over again. You can't make a different triangle with these 3 sides. There's only one possible triangle. The angles are set because of these sides. Similarly, in this one, well, in both of these, we have one angle and 2 sides. The key thing is how we name that. So if I have D, E, and F, this is 8, this is 10, and angle E is 100 up in here. So what you see here is we have 2 sides and the angle between them. So we have 2 sides and the angle between them. We call that SAS. So we had SSS, we have SAS. Now if we look at this one, GHI, see GH is 12, HI is 8. So in this one, it's not the included angle between the two of them, it's this angle over here, angle G, that's 30. And so you can see we have an angle and then a side and a side. So I'll write that out for you. We have an angle and then a side and a side. So in this situation, do you see the difference? I don't know why I'm asking you. You're not here with me to tell me. But the big deal here is, in this one, the angle was between the 2 sides, and in this one, the angle was off to the side. And what we're gonna see is there's only one possible triangle to build here. There's more than one possible triangle to build for this one that we're gonna see. So that's the answer to number 4 down here. They're all identical. And then not all identical. So then we see which set of building criteria were specific enough so that the group built the same standardized triangle. 1 and 2. So this is going to lead us to some very important conclusions in just a minute. Imagine you were coming up with the criteria for building project 4. Specify a set of measurements so that all groups will make congruent triangles. What's the minimum number of criteria you need and why? So there are an infinite number of answers to this. Basically, if you go off of what we did earlier, you are either going to make a triangle, you're going to give information where you give all three sides, or you give two sides and the angle in between them. And if you give either one of these situations, you're now making a situation where there's only one possible triangle. All right, let's move on to quick notes. So, triangle congruence. So we like to call these triangle congruence shortcuts. Some people call them the triangle congruence. Oh, these are conjectures right now. Yes. But it's eventually, we're eventually going to prove it, right? We prove it. But anyway, if we've got two different triangles and they both have one side that's congruent, and then they have another side that's congruent, and then the third side is congruent, then we're guaranteed to have two congruent triangles. So like if I called this one A, B, C, and then D, E, and F, well then we could say that triangle ABC is congruent to, and we have to name it the same way, right? So we did the one across from the triple first. So that I did A, B, C, so it needs to be the same order, D, E, F. If all three sets of sides are congruent, then the triangles are congruent. And this is called SSS, for side, side, side. The other one that we saw was SAS, or side, angle, side, and that was where we have two triangles, and we've got two sides, and then their included angle, and the other triangle, also, I drew that wrong. Pretend they're the same picture. They have to be the same picture. So the important part is that the included angle, so it's two sides and the included angle must be the included. So that's the one that's in between the two sides. And just to kind of touch on something, every math teacher knows this. Every math teacher dances around this. I wrote this in a specific order. The one that makes a funny word if you write it in the wrong order is bad. It didn't work. The A had to be between the two S's. All right. Let's determine if the triangles are congruent. If so, write a congruence statement and justify your answer using either SSS or SAS. And if not, explain why not. All right. So, well, let's see, 1, 2, and 3, and 1, 2. Yeah, so they have the same lines, the same congruence markings. So let's say, I see ABC. I'll call this one ABC. So triangle ABC is congruent to, let's see, well, A was across from the triple. So which one's across from the triple here? There's the triple. So D is across from the triple. Then B came next. B is across from the single. So E is across from the single. Oh, it is D, E, F. Okay. But if you had named it in a different order, like if I had written C first, C and then B, no, how about CAB? If I had written CAB, well, C is across from the double. So in this triangle, F is across from the double. So we need to write F first. And then I wrote A next, which was across from the triple. So here D is across from the triple. And then B is across from the single. That's E here. So FDE. So remember, naming these is very important that we follow the same convention with them. I see two sides. Oh wait, sorry, this was SSS. Those sides match and those sides match, but I don't have the third side. In case you've missed it, literally every lesson since we've learned vertical angles has had vertical angles in them somewhere. Oh, is it actually basically every lesson? If it's not literally every lesson, it's close. Almost every lesson we've done this year after we learned vertical angles has had vertical angles in them. Boom, vertical angles. Look, those are congruent because they're vertical angles. Oh wait, now I have two sides and the angle between them. Two sides and the angle between them. That is side, angle, side. Yay! All right. Fill in the missing statements and reasons to prove that the two triangles are congruent. If something is already marked, right, given. So, boom, boom, I know those are equal. Hey, now I've got SAS. So we know DS is TS because of, that's given. Vertical angles are congruent. Oh, so that's this one here. So I could say angle RST is congruent. Now, when you name angles, you want to do the same kind of thing. So I'm talking about the angle from double side to the angle to single side. So when I name it in the other triangle, I'm going to want to name it this double side to the angle to single side. So that's going to be BSD. And then what else is given? So we said the singles were the same, the angles the same, and then the doubles are the same. That is side BS is congruent. I don't want to say SR. I want to do the same direction. So B to S, so then R to S. So now I can say triangle RST is congruent to triangle BSD. All right, let's see. Next one. What additional information is needed to prove that the two triangles are congruent using SAS? Well, if I want to use SAS, I need the A in the middle of the two sides. Well, I got the two sides, so I would need this in the middle. I need this in the middle. So I am a big fan of letting my students write the actual, or draw on their diagrams and not actually write what it is. But I would accept this. You could also just write angle L needs to be congruent to angle H. All right. And then number 4, is M congruent to angle Q? How do you know? At first, you might be like, well, we don't have any angles. But check this out. We got two sides. On its own, that's not enough. But look, they share this third side. So we could put a triple line on this third side. And now both triangles have single, double, triple, single, double, triple. These are congruent triangles. So SSS congruence. And guess what? Since the triangles are congruent, all their angles are the same. So both M and Q are across from the triple line. So M and Q have to be equal to each other. Because M and Q are corresponding. They're in the same spot. So they are congruent. All right. And that was the corresponding parts of congruent triangles are congruent, the CPCTC. I don't really need you to write that acronym. I just want to make sure I say it. All right, now we have homework. Or practice, really. Yeah, I'm gonna call it practice. So it's just a matter of going through and seeing, is this SSS, is this SAS, or is it neither? And let's do one that's neither, just so that you have that in your back pocket. So let's look at number 2. Number 2, they share a side, so I can put a double line on that side. Now look closely. In our first triangle, we have two sides and the angle. So the sides and the included angle. In the other triangle, it's two sides this angle's not in between them. This angle would have to be here. If this was over here and not over here, we'd be good. But since it's over here, this fails. So stated the two triangles are congruent. These are not congruent. And when we write not congruent, I want to be clear, that's not saying I'm guaranteeing these triangles aren't congruent, because there's a possibility that if we learn some more information about them, they are actually the same triangle. There is not enough information to say that they definitely are congruent. So that's why we say not congruent. If you want to be a little pedantic, you could say not necessarily congruent, but like seriously, we're just gonna say nah. But then like on something like this, they share that side, so we can put like, I already have the double line, so we can put a single line. You can put triple line too, it doesn't matter. And so I got double, triple, and then the angle that they share in the middle. Double, triple, angle they share in the middle. So that's the two sides and then the angle in the middle. So that one is congruent. So that's what we're doing for these. And then on the back, can't feel. That was way more difficult than it needed to be.
You good?
Yeah, I'm good, Mr. Seifert. I'm just filming a video lesson. So on this one, we're just gonna add in the markings like we did in the worksheet. Bye.